Okay, let's just continue our discussion about the get. So for the get, well, the old way or the way we have already learned is that we do the dictionary dot get and then we use a key. It doesn't matter if the key exists or not in the dictionary. But now let's see the new version. So for the new version, we can actually specify a second parameter. So the role of the second parameter is if the such given key does not exist in the dictionary, and then we can specify what can be the return value. Okay, so let's do the fruit in inventory again. Well, if I'm trying to get a cherry. Well, if we don't have cherry, and then I'm gonna instead of having a none, I want to return a 0 saying I don't have cherries, and then I can do this like this. So inventory, which is a dictionary name, and then dot get and cherry. Cherries is the first parameter, that is the key I'm looking for, and then I'm also specifying a 0, that is if we don't have such a key cherry, and then instead of returning a none, I want to return a 0. Okay, well, and we can also do the same thing for apples. We are trying to use the apples as a key to get the value. If we get the value, and then that will be the return value. However, if there's no such key apple, I'm gonna have a 0 as well. Well, if you look into a dictionary, here I do have apples as the key. So in this case, even though I specified 0 as a backup plan, but this is not used because I do have apples in my dictionary. So I'm gonna grab the corresponding value using the apples as a key. Okay, well, and even fancier, we can do this. So I want to get the peaches. If there's no peaches, and then I can return a string. That is code. We don't have peaches, and this works as well. Okay, so well, this gives you more flexibility on try to grab a value using a key, and then if this key does not exist, and then you can also tailor what will be the return value. Isn't it cool? Okay, so the next thing, we want to talk about how and why we want to use tuples as indexes. And let me give you this example. Say I have a matrix. Well, this is a nested list, and we have already seen that. Okay, and in this nested list, and then one observation I have is this nested list or this matrix is really sparse. And by saying it is sparse, I mean there are way too many zeros and then any other values, any non-zero values. Okay, so if you count, there are only 1, 2, 3. There are only 3 non-zero values. But to store the whole matrix, well, we are storing a big nested list, but only 3 of them are non-zero values. Well, and this can be a concern because we are wasting a lot of the storage space, right? And in scientific computing, you're going to see this kind of the sparse matrix a lot. So my idea is, can we store the information in a different way? Because there are only 3 non-zero values. So how about I just record the x and y coordinates of the non-zero values? Okay, so let's see another version. So for this version, I'm recording on the index 0 and 3, there is a 1. So for the parentheses, for the tuple, I'm recording the x and y coordinates or the indexes for in the nested matrix so that I can grab that value. So let's take a look on the 1 again. So to get this 1, that is the index 0, which is the first row, and then index 3, which is the fourth item, right? So if we are using the square bracket 0 and then a 3, we are able to get this value 1. So now I want to put this information in a different way. I want to create a dictionary. On this dictionary, I'm using a tuple as a key, and that key represents the x and y coordinates or the possible indexes for the matrix in order to get the non-zero value, and then colon. So for the value, I'm just recording what is the non-zero value. Okay, so I want to transform such a matrix into this way. So there are only three entries. They are, well, on the x as a 0 and y as 3, there is a non-zero value 1. On the x coordinates as 2 and then y coordinate as a 1, there is another non-zero value as 2. There on the x coordinate 4 and then y coordinate 3, there is another non-zero value as 3. Okay, those are only three non-zero values, and I'm using the xy coordinates as a key and then the value as the value in the dictionary, and then ta-da, I got this sparse matrix stored. Okay, so this is just a cool trick that we can use to store a sparse matrix. And another new thing here is, well, what data type are we using as the keys? We are using tuples, right? So my question is, can we use tuples as the keys? Or in Python's dictionary, what is the rule for choosing the data or choosing the data types to be the keys? There was a rule. The rule is, for the keys in dictionaries, they have to be immutable, right? So can we use tuples as the keys in the dictionary? The answer is yes, because tuples are immutable. Okay, so let me ask another question. Can we use lists as the keys in dictionaries? Sorry, can we use the lists as the keys in dictionaries in Python? No, because for the lists, they are mutable. By saying they are mutable, this means they are not qualified to be the keys in dictionary. Okay, so after we have the matrix stored in this way, now if we specify a xy coordinate, we will be able to get the value. So how about we do this? So for the matrix, we want to get the value on the 0 and 3 as the x and y coordinate. So 0 and 3 will be the key. We do a search and then we will get a 1. So on the x and y coordinates 0 and 3, there is a non-zero value 1 there. So even better, how about we do this version? So for this version, we are going to use a get to get the value on the 1, 3 as the x and y coordinate. If there is a non-zero value, I'm going to grab the non-zero value from the matrix as a dictionary. Otherwise, I'm going to return a 0 saying if that xy coordinate is not required, it's not recorded in my matrix, and then this means there has to be a 0 there. Okay, so this is just a cool trick that we make use of the tuples as the keys in the dictionary so that we can store such a sparse matrix into a dictionary. Okay, so let's see a few more exercises. So we have the my dictionary, cat 12 and dog 6, elephant 23, and then bear 20. So if I want to print my dictionary dogs, what am I gonna have? It's gonna be A. Why? Because I'm using dog. So we don't have such a key dogs in our dictionary, and then I'm grabbing the value using dogs without using get. So I'm gonna have an error. So how about the next one? If I want to do the my dictionary.get dogs, so in this case, what am I gonna get? I'm gonna get a none because in this case I'm using get. That is a safe way. So if there's no such key dogs, and then I'm gonna return a none. Okay, how about the next one? So we have an inventory of the 4 fruits, and then I want to do for a key in inventory, and then I'm print a key. So what am I gonna print? I'm gonna print all the keys, including apples, bananas, oranges, and pears. So the next question is, am I gonna see those apples, bananas, orange, and pears in that sequence? The answer is no, it's not guaranteed, because in Python, a dictionary is an unordered collection of objects. So it's very likely that you are going to see apples, bananas, oranges, and pears in this sequence, but there's no guarantee for that. Okay, so the last one. We have a total, and then we have a dictionary of the four animals. And if we are visiting all the keys for a key in my dictionary, and then if the length of my key is greater than 3, I'm adding the corresponding value to my total. So what am I gonna have? Think about that. The correct answer will be B, 43. So the reason is here in this iteration, I'm going to visit all the keys. And then for each of the key can be cat, dog, elephant, or bear. And if the length of this key is greater than 3, so we are checking the length of the keys as strings, right? So the length of the cat is a 3, the length of the dog is a 3. So, well, for those two, the lengths are not greater than 3, so we are not adding 12 or 6. Elephant, yes, the length is greater than 3, so I'm adding the 23 to the total. And then for the bear, the length is a 4, so I'm also adding 20 to the total. So I'm adding 0, 23, and a 20, so I'm gonna get a total of 43. Okay, so that's it for today. And then for today's exercise, I will still post that, and I will also give you the answer key. So this means there's no daily exercise for today. And before we finish, let me remind you again, well, please go ahead and do the class evaluation. Okay, well, if the class evaluation is higher than 66%, I'm going to drop the 2 lowest scores of your daily exercises and plus 2 of your missed Flipgrid participations. Okay, so take a deep breath. We have finished this course. Congratulations. But still, well, there's a final exam. So good luck.